We can break matter down into different categories. Pure substances are either elements or compounds. Mixtures are either homogeneous or heterogeneous. In the category pure substances, elements cannot be broken down by chemical means. All elements have their own spot in the periodic table. All atoms are of the same type. Examples would be oxygen, hydrogen, and gold. A compound contains atoms of two or more elements bonded together so that the resulting substance has its own properties. A compound can be separated into its own elements or broken down into simpler compounds. Examples would be water, carbon dioxide, and sodium chloride. This slide shows examples of helium, an element, and water, a compound. Mixtures, as the name implies, contain more than one pure substance. The substances have not reacted but retained their own identity. There are two different types of mixtures. In a homogeneous mixture, the components are spread evenly, so that even under a light microscope one would only see one phase. Examples include air, salt water, and alloys such as brass. In a heterogeneous mixture, one can at least under a light microscope see that the components are not completely blended together. Examples would be blood, omelets, and spaghetti with meatballs. Here are other examples of homogeneous and heterogeneous mixtures. Again, we have air as an example of a homogeneous mixture as well as seawater. For a heterogeneous mixture, we have some sort of a soup mix. We describe the different types of matter using physical and chemical properties. Physical properties describe a substance without trying to change it into another one. We might describe its color, density, melting point, boiling point, or whether or not it conducts electricity. With chemical properties, we describe the chemical reactions the substance may or may not undergo. Does it burn? Is it easily oxidized? Does it react with water? We are talking about at least trying to change the identity of the substance. The difference between physical and chemical changes is that physical changes leave the substance intact, while the chemical changes result in the formation of new substances. Examples of physical changes include phase changes or things like pulverizing. An example of a chemical change might be rusting or the reaction food undergoes when it cooks. In this slide we see examples of physical and chemical changes. In the picture to the left, if you don't snap the flint, the butane goes from the liquid phase to the gas phase, but remains butane. In the picture to the right, the butane has been ignited. In the chemical change, it is transformed into carbon dioxide and water. Mixtures can always, at least theoretically, be separated by taking advantage of the different physical properties of the substances involved. In distillation, one can separate solids from liquids or two liquids at different boiling points. One would do this to separate alcohol from mash and excess water when making moonshine. One might use filtration to separate solids from liquids. One is in essence doing filtration when one makes coffee. A major advance responsible for the start of chemistry as a science was the discovery of the law of conservation of mass, or matter. All chemical changes follow the law of conservation of mass. In this slide we see that a certain mass of butane reacts with a certain mass of oxygen to make a certain amount of water and carbon dioxide. The mass of the reacting chemicals, butane and oxygen, is equal to the mass of the products, water and carbon dioxide.